Japanese adults over 60 consume less total protein per day than Americans, about 70 to 80 grams daily against the 100 or more grams that American health culture increasingly promotes as the minimum for muscle preservation in older adults. And yet the rates of sarcopenia, the age-related muscle loss that drives frailty, falls, and loss of independence in the elderly, are significantly lower in Japan than in the United States. This is not explained by genetics. Japanese Americans who adopt a Western dietary pattern show sarcopenia rates that converge with the general American population within a generation. The protection travels with the food. The explanation lies in a concept that most muscle-building content never addresses: anabolic resistance. After 60, the aging muscle loses its ability to respond normally to the protein it receives. The same amount of protein that would efficiently trigger muscle protein synthesis in a 30-year-old produces a blunted, insufficient response in a 65-year-old. The muscle is receiving the raw materials. It is simply failing to use them. This is why eating more protein often does not solve the problem. The bottleneck is not supply. It is the signaling cascade that converts dietary protein into muscle tissue, a cascade that inflammation, declining hormonal activity, and specific nutritional deficiencies progressively impair with age. The three foods that Japanese elders consume consistently, not as interventions, but as ordinary daily meals that have remained unchanged across generations, address this specific bottleneck through three distinct mechanisms. None of them is primarily a high-protein food. All of them make protein work better. Today, I'm going to show you all three. And at the end, I will tell you something about what the Japanese dietary pattern achieves that no supplement protocol has yet replicated, and why the combination of these three foods in the same day may matter as much as the individual compounds they contain. Stay until the end. Food 1. Salmon. Consumed several times weekly, never as a steak. The Japanese relationship with salmon is different from the Western one. It is not a centerpiece protein portion. It is flaked into rice, dissolved into miso soup, layered into bento boxes, consumed in small amounts at multiple meals rather than in large portions at one. This distinction matters for the muscle biology in ways that only became clear with the research on anabolic resistance. A randomized controlled trial published in the American Journal of Clinical Nutrition, the most comprehensive investigation of omega-3 fatty acids and muscle protein synthesis in older adults, found something remarkable. Omega-3 fatty acid supplementation had no effect on the baseline rate of muscle protein synthesis. None. But when the researchers added amino acids and insulin to the equation, simulating the conditions of a protein-containing meal, the omega-3 group showed a more than threefold increase in the muscle protein synthesis response compared to the control group. The anabolic response to the same protein meal was dramatically amplified by the presence of EPA and DHA. The mechanism runs through the mTOR signaling pathway, the same pathway that leucine activates as the primary trigger of muscle protein synthesis. EPA and DHA appear to sensitize the aging muscle cell to the amino acid signals it is receiving, restoring a responsiveness that inflammation and aging have blunted. The muscle does not need more protein. It needs the signaling environment that allows it to respond to the protein it already has. Inflammation is the primary driver of anabolic resistance in aging muscle. The inflammatory cytokines TNF-alpha and interleukin-6 that accumulate with age directly interfere with mTOR signaling. EPA and DHA suppress both through the same anti-inflammatory pathway that protects the cardiovascular system, which is why the populations with the best cardiovascular markers also tend to have the best muscle preservation outcomes. The mechanism is shared. The Japanese elders consuming salmon several times weekly were not supplementing EPA and DHA. They were eating fish the way their culture had always prepared it, in small amounts, with vegetables, across multiple meals, in a dietary pattern that maintained serum omega-3 levels high enough to sustain the anti-inflammatory environment that makes protein work. Food 2. Ica, squid. Squid is the most consumed cephalopod in Japan. Grilled, simmered, dried, served in small amounts as accompaniment to rice or sake or as part of a bento, it appears in the Japanese diet with a frequency that no Western food culture approximates. And it contains something that almost no Western food discourse ever mentions in the context of muscle aging: taurine. Squid has among the highest taurine concentrations of any food ever measured, substantially higher than beef, chicken, or even other seafood. And taurine, once considered a minor conditional amino acid with limited metabolic relevance, has become one of the most actively researched compounds in the sarcopenia literature. A comprehensive review published in PMC established that taurine levels in skeletal muscle decline progressively with age, and that skeletal muscle depleted of taurine develops abnormalities in morphology and function that closely mirror the changes seen in sarcopenia. The muscle is not just losing mass, it is losing the compound that maintains the excitation-contraction coupling wall, the electrochemical process that converts neural signals into muscle force, and that regulates the calcium homeostasis that determines how efficiently muscle fibers contract and recover. A 2024 longitudinal study from Japan's National Institute for Longevity Sciences tracked Japanese adults over 8 years and found that taurine intake was significantly associated with maintenance of physical fitness across the follow-up period. The researchers specifically identified shellfish and cephalopods, the categories that include squid, as the primary dietary sources maintaining adequate taurine status in the elderly cohort. Before Food 3. Subscribe to Longevity Code. Every week we decode one longevity population, one food system, one set of mechanisms, always peer-reviewed, always practical, always something specific. You can start this week. The taurine in squid is arriving in a food matrix that also delivers vitamin B12, zinc, and iodine simultaneously. All three nutrients with documented independent roles in muscle function and neurological integrity that the research on sarcopenia identifies as commonly deficient in elderly populations. The squid is not a protein source delivering taurine on the side. It is a complete nutritional package for aging muscle that happens to taste good grilled with soy sauce. The Japanese elders consuming Ica regularly were not doing so because of any awareness of taurine or sarcopenia research. They were eating what the sea around them had always provided, prepared the way their families had always prepared it. The biology simply reflected what consistent, lifelong taurine delivery looks like in skeletal muscle across 80 years. Food 3. Soba. The grain with the amino acid profile that rice and wheat cannot match. Most discussions of carbohydrate and muscle aging focus on what carbohydrates do after digestion, their glycemic impact, their insulin response, their effect on fat storage. Almost none of them address what the grain delivers before the starch, the amino acid profile of the protein fraction that arrives alongside the carbohydrate. Buckwheat, the grain from which 100% soba is made, contains all 9 essential amino acids. This is rare for a plant food. Rice does not. Wheat does not. Most grains are deficient in lysine, the essential amino acid that is rate-limiting for muscle protein synthesis and collagen production, the amino acid that the aging body needs in the greatest relative quantity, and that the standard Japanese grain alternatives, white rice and refined wheat, do not adequately supply. Lysine is not the trigger of muscle protein synthesis. That is leucine's role. Lysine is the rate-limiting substrate. When lysine is insufficient, the leucine trigger activates the machinery, but the machinery runs out of raw materials before the synthesis cycle completes. The muscle attempts to rebuild. It cannot finish the job. The buckwheat soba that Japanese elders consume, cold in summer with dipping sauce, hot in winter in noodle soup, provides a complete amino acid profile with adequate lysine at every serving, alongside the salmon delivering EPA and DHA that sensitizes the mTOR pathway to amino acid signals, and alongside the squid delivering the taurine that maintains muscle fiber contractility and calcium homeostasis. The soba is completing the amino acid matrix that the other 2 foods initiate. The 3 mechanisms are additive. The salmon addresses the signaling environment, making aging muscle responsive to protein again. The squid addresses the contractile and structural integrity, maintaining the electrochemical and calcium-dependent processes that keep existing muscle fibers functioning. The soba addresses the substrate availability, ensuring the complete amino acid pool is present when the synthesis machinery activates. None of these foods, consumed in isolation, would produce the outcome. Together, consumed consistently across a lifetime in a dietary pattern that integrates them naturally, they created the muscle profiles that researchers studying Japanese elders consistently found remarkable. Not because of exceptional genetics or exceptional effort, but because of ordinary food consumed the ordinary way every ordinary day. Now, the distribution piece. The research on protein timing in elderly muscle has converged on a principle that the Japanese dietary pattern has followed for centuries without knowing the biology. Distributing protein intake evenly across multiple small meals produces significantly better muscle protein synthesis outcomes than concentrating the same protein into 1 or 2 large meals. The aging muscle's anabolic window is narrow and refractory. Small, frequent doses of complete amino acids maintain a more continuous synthesis signal than large, infrequent doses that overwhelm the machinery in one sitting and leave it dormant for hours. The Japanese meals that deliver salmon, squid, and soba in small amounts at breakfast, lunch, and dinner were not designed around protein timing research. They were designed around the cultural principle that every meal should be balanced, modest in quantity, and varied in composition. Each meal provides a small protein stimulus from multiple sources: fish, fermented soy, shellfish, grain, arriving together in a food matrix that includes the omega-3s to sensitize the mTOR pathway, the taurine to maintain fiber contractility, and the complete amino acid profile to give the synthesis machinery everything it needs to finish the job. The outcome was not designed. It was the inevitable biological consequence of a food culture that distributed the right nutrients across the day, in the right combinations, across decades of consistent daily meals. The Japanese elders were not optimizing their protein timing. They were eating lunch. Which of these 3 mechanisms surprises you most? The anabolic resistance piece with salmon, the taurine in squid, or the complete protein in soba? Tell me in the comments. Subscribe to Longevity Code. Next week, another Japanese food system, another population, another set of mechanisms that traditional food cultures figured out long before the research arrived to explain why. Always the science. Always something you can start this week.